guys! Welcome back to my channel. So for today's video, I'm going to share with you the content and summary of what I've learned in CCNAv7 Module 13. So hello, welcome to the last module, Module 13. So CCNAv7, Bridging SRWE course, Switching, Routing, and Wireless Essentials. So in Module 13, it is a WLAN configuration. Excuse me. So you will learn in this module title, WLAN configuration. The module objective is to implement a WLAN using a wireless router and WLC. Next slide. Module 13.1 Remote Site WLAN Configuration. Configure a WLAN to support a remote site. Includes the wireless router, log into the wireless router, basic network setup, basic wireless setup, configure a wireless mesh network, NAT for IPv4, quality of service, port forwarding. So let's browse the following. Let us browse the following here at Cisco Net Acad. Excuse me. So here it is. The WLAN configuration, the Module 13, CapWAP operation. So let's watch
Let's discuss CapWAP. Control and provisioning of wireless access points. CapWAP is an IEEE standard protocol that enables a wireless LAN controller to manage multiple access points and wireless local area networks. CapWAP is responsible for the encapsulation and the forwarding of wireless LAN client traffic between an access point and a wireless LAN controller. CapWAP is going to establish tunnels on UDP ports 5246 and 5247. This is with IPv4 and with IPv6. CapWAP will also provide additional security with DTLS encryption, which is Datagram Transport Layer Security. A key component of CapWAP is the concept of split media access control. With this, we're going to have the functions normally performed by an individual access point distributed across two functional components. The first functional component being the access point MAC function. That's going to be handling the beacons and probe responses, packet acknowledgements and retransmissions, frame queuing and packet prioritization, and MAC layer data encryption and decryption.
So in this video or in this module, we will learn about control and provisioning of wireless access points or the CapWAP. So introduction to CapWAP. Module 13.2 Configure basic WLAN on WLC. But before that, let's go back here at the introduction. Introduction to CapWAP. Introduction, CapWAP is an IEEE standard protocol that enables a WLC to manage multiple APs and WLANs. CapWAP is also responsible for the encapsulation and forwarding of WLAN client traffic between an AP and a WC. So here are the AP, 3AP, and the WLC. So CapWAP is based on LWAPP but adds additional security with Datagram Transport Layer Security or DTLS. The CapWAP establishes tunnels on user datagram protocol or UDP ports. CapWAP can operate either over IPv4 or IPv6 as shown in the figure but uses IPv4 by default. So IPv4 and IPv6 can use UDP ports 5246 and 5247. However, CapWAP tunnels use different IP protocols in the frame header. IPv4 uses protocol 17 and IPv6 uses IP protocol 136. So next, split MAC architecture. A key component of CAPWAP is the concept of a split media access control or MAC. The CAPWAP split MAC concept does all of the functions normally performed by individual APs and distributes them between two functional components. The AP MAC functions and the WLC MAC functions includes here. So DTLS encryption. DTLS is a protocol which provides security between an AP and the WLC. It allows them to communicate using encryption and prevents eavesdropping or tampering. CAPWAP encapsulation. DTLS encryption enabled by default. DTLS encryption disabled by default. The AP and the WLC rather. So Flex Connect APs. There are two modes operation for the Flex Connect AP, the connected mode and the standalone mode. The WLC is reachable. In this mode, the Flex Connect AP has CAPWAP connectivity with its WLC and can send traffic through the CAPWAP tunnel, as shown in this figure. The WLC performs all its CAPWAP functions. So from here to here. So standalone mode, the WLC is unreachable. The Flex Connect has lost or failed to establish CAPWAP connectivity with its WLC. In this mode, a Flex Connect AP can assume some of the WLC functions such as switching, client data traffic locally, and performing client authentication locally. So next is remote site WLAN configuration. The module 13.1. Remote site WLAN configuration is to configure a WLAN to support a remote site. Includes the wireless router, how to log into the wireless router, the basic network setup, basic wireless setup, configure a wireless mesh network, not for IPv4 as I have said earlier, the quality of service, and port forwarding. 13.1. So, these are the following. You can browse it more for you to be able catch some understandings about this. Like for example, the wireless router, the Cisco Meraki MX64W. Log into the wireless network. Most wireless routers are ready for service out of the box. They are pre-configured to be connected to the network and provide services. Like for example, the wireless router uses DHCP to automatically provide address and information to connected devices. However, wireless router default IP addresses, usernames, and passwords can easily be found on the internet. Just enter the search phrase default wireless router IP address or default wireless router passwords to see a listing of many websites that provide this information. Excuse me. So let, for example, username and password for the wireless router in the figures is admin. Therefore, your first priority should be to change these defaults for security reasons. Like because if you enter your name and your friend access it, it will easily know your password and can hack your account. So again, check your wireless router's documentation is search the internet. So web browser 192.168.01, that is your IP address, the username, like for example admin, and your password is admin. Just click OK. Basic network setup. So basic network setup. Basic network setup includes the following steps. Log into the router from a web browser. Change the default administrative password. Log into the router from a web browser. Change the default administrative password. Log into the new administrative password. Change the default DHCP IPv4 addresses. Renew the IP address. And last, log into the router with the new IP address. So, as you can see here, enter the router's new IP address to regain access to the router configuration GUI as shown in the example. You are now ready to continue configuring the router for wireless access. So, each of the following includes some explanation for you to understand it more. So, basic wireless setup. The basic wireless setup. Basic wireless setup includes the following step: view the WLAN defaults, change the network mode, configure the SSID, configure the channel, configure the security mode, configure the passphrase. So likewise, in basic network setup, just click each step for more information and example GUI. So here, number 1, number 2, the change the network mode, configure the SSID, configure the channel, configure the security mode, and configure the passphrase. Just always remember to read the following for you to know more information. Okay, next is configure a wireless mesh network. Configure a wireless mesh network. Not for IPv4. Quality of service. Many wireless routers have an opinion for configuring quality of service or QoS. By configuring QoS, you can guarantee that certain traffic types such as voice and video are prioritized over traffic that is not as time sensitive, such as email and web browsing. So on some wireless routers, traffic can also be prioritized on specific ports. So analyze this figure. Port forwarding. The last one for module 13.1 is port forwarding. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of a LAN. However, there are situations when specific ports must be open so that certain programs like and applications can communicate with devices on different networks. So, port forwarding is a rule-based method of directing traffic between devices on separate networks. So, when traffic reaches the router determines if the traffic should be forwarded to a certain device based on the port number found with the traffic. Like for example, a router might be configured to forward port 80, which is associated with HTTP. So when the router receives a packet with the destination port of 80, the router forwards the traffic to the server inside the network, and that serves web pages. So in this figure, port forwarding is enabled for port 80 and is associated with the web server at IPv4 address 10.10.10.50. So as shown in this figure, so, port triggering allows the router to temporarily forward data through inbound ports to a specific device. Next is Module 13.2, the configure basic WLAN on the WLC, the 13.3 configure enterprise WLAN on the WLC, and troubleshoot WLAN issues in 13.4. So, Module 13.2, configure a basic WLAN on the WLC. It configures WLC WLAN to use the management interface and WPA2 PSK authentication. Includes WLC topology, log into the WLC, view AP information, advanced settings, and configure a WLAN. Next, Module 13.3, configure WPA2 enterprise WLAN on the WLC. So in this module, we will configure WLC WLAN to UC VLAN interface, a DHCP server, and WPA2 enterprise authentication. Includes here are the SNMP and radios. Configure SNMP server information. Configure radio server information. Topology VLAN 5 addressing. Configure a new interface. Configure DHCP scope. Configure WPA2 enterprise WLAN. And the last module, module 13.4, troubleshoot WLAN issues. Troubleshoot common wireless configuration issues. So, wireless client not connecting, troubleshooting when the network is low, and updating firmware. So, here at 13.4, troubleshoot WLAN issues, troubleshooting approaches. So, network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This process is called troubleshooting. So, troubleshooting any sort of network problem should follow a systematic approach. A common and efficient troubleshooting methodology is based on the scientific method and can be broken into the 6 main steps shown in the table. Step 1, identify the problem. Step 2, establish a theory of probable causes. 3, test the theory of determined cause. 4, establish a plan of action to resolve the problem and implement the solution. 5th, verify full system functionality and implement preventive measures. Last step is document findings, actions, and outcomes. So, here are the descriptions. To assess the problem, determine how many devices on the network are experiencing the problem. If there is a problem with one device on the network, start the troubleshooting, of course, process at the device. If there is a problem with all devices on the network, start the troubleshooting process at the device where all other devices are connected. So the students should develop a logical and consistent method for diagnosing network problems by eliminating one problem at a time. So, wireless client not connecting. When troubleshooting a WLAN, a process of elimination is recommended. So, in this figure, a wireless client is not connecting to the WLAN. So, if there is no connectivity, check the following. So, confirm the network configuration, the PC using the ipconfig command. So, if the PC is operational but the wireless connection is performing poorly, check the following. Check this out. So, next, ensure that all the devices are actually in place. Consider possible physical security issue. Is there power to all devices and are they powered on? So, finally, inspect links between cable devices looking for bad connectors or damaged or missing cables. If the physical plant is in place, verify the wired LAN by pinging devices, including the AP. If connectivity still fails at this point, perhaps something is wrong with the AP or its configuration. So when the user PC is eliminated as the source of the problem and the physical status of devices is confirmed, begin investigating the performance of the AP and check the power status of the AP. So, troubleshooting when the network is low. To optimize and increase the bandwidth of 802.11 dual band routers and APs, either upgrade your wireless clients or split the traffic. Example of split the traffic, like for example, use the 2.4 GHz network for basic internet tasks such as web browsing, email, and downloads, and use the 5 GHz band for streaming multimedia as shown in this figure. So there are several reasons for using a split that traffic approach. So just read this. So to improve the range of a wireless network, ensure the wireless router or AP location is free of obstructions such as furniture, fixtures, and tall appliances. So this block the signal, which shortens the range of the WLAN. And, if this is still does not solve the problem, then a Wi-Fi range extender or deploying the power line wireless technology may be used. Last, updating firmware. Most wireless routers and APs offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers as well as security vulnerabilities. So you should periodically check the router or AP for updated firmware. In this figure, the network administrator is verifying that the firmware is up to date on a Cisco Meraki AP. So access point setup. This access point is registered on the Meraki cloud. Utilization 66%. Ethernet connectivity. This access point is directly connected to a local network. IP address includes here. The internet connectivity. This access point is connected to the internet. Cloud management connectivity. This access point is successfully connected to the Meraki cloud. And firmware. This access point's firmware is up to date. So on a WLC, there will most likely be the ability to upgrade the firmware on all APs that the WLC controls. So, in the next figure, the network administrator is downloading the firmware image that will be used to upgrade all the APs. So, as you can see here, asking, are you sure you want to pre-download the primary image for all apps associated? Includes here, AP virtual IP address. So in a Cisco 350 for wireless controller, click the wireless tab, then access points from the left menu, global configuration submenu, then scroll to the bottom of the page for the AP image pre-download section. Just understand or analyze this picture for you to be able to know the following. So that's all, guys, for Module 13, the WLAN configuration. And always remember, when you need some, what do you call that? So when you need an information about WLAN configuration, just browse the following. From here, Module 13.1 to Module 13.3. And you will be successful in WLAN configuration. So guys, thank you for watching and listening in this video, and of course in this Module 13.